continue with some polar graphs. Now last time we wound up graphing a certain type called limesons. On this lesson I want to focus on graphing what we call roses. And these are polar equations that take on this form. R is equal to a sine n theta or a cosine n theta, where n is a positive integer and a is a real number. So let's jump right into an example. Let's graph r equal 4 cosine 2 theta. So how are we going to do this? Well, we know how to do this. We're going to make a table, right? So I make a long table of values here for r and theta, and I'll start with theta equals 0. And I'm going to plug that in for theta in my equation and figure out r. Now notice we're multiplying each angle by 2 before we evaluate the cosine. All right, so more on that in a second. So I'm going to plug in 0 for theta, multiply by 2, I still get 0. What's the cosine of 0? 1 times 4 is 4. So our first point is 0, 4. And we are well on our way. Well, not yet. So what should I do next? How about pi over 6? And then I'm going to plug that into theta, and I'm going to double it, which gives me pi over 3. And then the cosine of pi over 3 is 1/2 times 4 is 2. So I'm going to get r equals 2 at pi over 6. Now this is where I don't want you to get confused. When we plug in pi over 6 for theta and we double it, that gives us pi over 3. But we're not graphing at pi over 3 on this graph. We're evaluating the cosine of pi over 3. So if you're thinking of the unit circle and you have a separate picture of that, go to pi over 3 on the unit circle, evaluate the cosine of that, which is 1/2 times 4. But now when I plot my point, I'm going to pi over 6, and then I'm going 2 units out. So sometimes that students can get mixed up with that when you're doing your graph. So at pi over 6, I go out to 2. Notice r is getting smaller. Then if I go to pi over 4, and I plug that in, I double it, which gives me pi over 2. What's the cosine of pi over 2? Well, that's 0 times 4 is 0. So notice that as I went from 0 to pi over 4, my r value went from 4 all the way down to 0. So from 0 to pi over 4, my r values on my graph are getting smaller and smaller and going right to the pole. So I'm going to actually go ahead and draw part of my graph right off the bat here. And that's what I've got so far. Okay, let's keep going. Let's do pi over 3. So I'm going to plug that in, double it, I get 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2 times 4 gives me negative 2. So notice from pi over 4, as I start going this way, I wind up getting negative r values. So for all these angles here, I'm going to be plotting points down across here. And so I'm getting negative r values. So let's go ahead and plot that point. So at pi over 3, I'm going 2 in the opposite direction, so that's down there. Okay, and then I'm going to go to pi over 2. When I plug that in for theta in my equation, I double it, which gives me pi. Cosine of pi is negative 1 times 4 is negative 4. So by the time I'm at pi over 2, I'm way down here when I'm plotting points. So notice these r values are getting more negative as we go, which means my graph was 0 at pi over 4, and now I have negative r values, and we're down there. Okay, we keep going. We go 2 pi over 3. Now I'll start going through the evaluations more quickly. So if you want to hit pause and try them yourself or fill out the table yourself first, might be a good idea. 2 pi over 3, I double it, gives me 4 pi over 3. The cosine is negative 1/2 times 4 is negative 2. So at 2 pi over 3, I'm going 2 in the opposite direction. Notice my r's are getting less negative. Then at 3 pi over 4, when I double that, I get 3 pi over 2. Cosine of that is 0 times 4 is 0. So by the time I get to 3 pi over 4, I'm back at 0 again. So notice my points on my graph are going back in that direction. And there's one of my complete leaves for my rows. Okay, after 3 pi over 4, what are we going to choose? 5 pi over 6. When I double that, I get 5 pi over 3. Cosine of 5 pi over 3 is positive 1/2 times 4 is positive 2. So at 5 pi over 6, now I'm graphing points back over here. And then at pi, I'm going to double that and get 2 pi, and the cosine of 2 pi is 1 times 4 is 4. So when I plot that, I'm all the way back out here. So notice as I went from 3 pi over 4 to pi on my graph, my R values were getting bigger. And they went all the way out to here. All right, now I think I'm going to have to make another 2 columns here for my graph because I'm running out of space. And maybe I'll start writing smaller. So I'm going to have 7 pi over 6. And then I plug that into theta and double it. That gives me 7 pi over 3. So now I'm going all the way around the unit circle. So all the way around once is 6 pi over 3, and then another 1 pi over 3 gives me the 7 pi over 3 that I've evaluated here. So I get cosine of 7 pi over 3 is the same as the cosine of pi over 3, which is 1/2, times 4 is 2. So at 7 pi over 6, let me plot that. I have 2 out. Looks like I'm going to complete my next leaf. And then at 5 pi over 4, I plug that in for theta. I double it. That's 5 pi over 2, or 2.5 pi. And so 2.5 pi is all the way around, and then pi over 2. Cosine of pi over 2 is 0 times 4 is 0. So at 5 pi over 4, I'm back at 0 again. And so my graph has gone back to there. Okay, 5 pi over 4, then we got 4 pi over 3. We double that, that's 8 pi over 3, which is 6 pi over 3, and another 2 pi over 3. Cosine of that is negative 1/2 times 4 is negative 2. So at 4 pi over 3, go 2 in the opposite direction, takes me up there, kind of in the first quadrant if we put our rectangular system on top of our polar graph. And then at 3 pi over 2, I'm going to double that, and I get 3 pi. Cosine of 3 pi is negative 1 times 4 is negative 4. So when I get to 3 pi over 2, I'm going 4 up instead of down. And you can see what's happening here. Now we're going back out. R is getting bigger again. And then we're going to do 5 pi over 3. We're going to plug that into theta. We're going to double it. So 5 pi over 3 doubled is 10 pi over 3. 10 pi over 3 is 6 pi over 3, and then another 4 pi over 3. Cosine of that is negative 1/2 times 4 is negative 2. So we go to 5 pi over 3, and we go 2 in the opposite direction. So that's over there. So you can see what's going to happen here. We're going to come back down. And I'm guessing at the next one we're going to get 0. Let's see how good my guess was. When I double that, I get 7 pi over 2, which is 3.5 pi. So I'm back at 3 pi over 2, and the cosine is 0 times 4 is 0. Wow. Lucky guess? No, we see the pattern here. See what's going on. So I'll just finish out the table with the last one here. We got 11 pi over 6. I double that, and it's 11 pi over 3. That's 6 pi over 3 and another 5 pi over 3. Cosine is 1/2 times 4 is 2. So we got 11 pi over 6, and then I'm going to go 2 units out. And then finally, I'm going to do 2 pi, double it, I get 4 pi. The cosine is still 1 times 4 is 4. And I am back to where I started, and I have completed my rows. So notice, the 4 in my equation wound up being the length of each of these petals, or each of these leaves in my rows, 4 units out. And that's because the biggest value of cosine can ever be is positive 1. So this number in front tells me the length of each of my petals. And then it was a 2 theta, and I wound up getting 4 leaves, or 4 petals. So I wonder if there's a pattern with that. Well, the best way to figure that out is to try another one. So what you might want to do here is hit pause, try and graph it yourself just to get the practice. It's so much different listening to somebody walk you through it than trying to do it yourself first. So learning by doing, much better than learning by watching. All right. Hopefully you took my advice and you tried this on your own first, but now I'll walk you through it. So R and theta. I already know when I plug in theta, this time I'm going to have to multiply the angles by 3. So let's see what happens when I do that. I plug in 0, 3 times 0 is still 0. Cosine of 0 is 1. So I start off at the same point that I did before. At 0 radians, I go 4 units out for r. All right, then I'm going to do pi over 6. Now, I'm plugging in pi over 6 for theta, multiply by 3, that gives me pi over 2. The cosine of pi over 2 is 0 times 4 is 0. Holy cow. So from just going from 0 to pi over 6, my r values are going from 4 all the way to 0. So that's happening very, very quickly. So my r values all of a sudden, boom, are shooting way down to 0 right off the bat. Okay, and then what happens after pi over 6? I'm guessing I'm going to start getting negative r values, which is going to wind up, instead of plotting points over here, they're going to be down here. So let's plug in the next angle, pi over 4. Now I'm going to write this out because I multiply by 3, and I have to do the cosine of 3 pi over 4. Well, that's negative square root of 2 over 2. And then I multiply that by 4, and I'm going to get negative 2 root 2, which, gosh, I'm not going to get a nice answer for this, am I? But I know that's the same as negative root 8, which is a little less than negative root 9. So it's going to be, instead of negative 3, how about it's approximately negative, let's say 2.8? You can check that on a calculator. I'm guessing that's going to be pretty close. But I'm just going to eyeball it in my graph anyway, so it doesn't have to be accurate to more than 1 decimal. So at pi over 4, so let's look at our graph. So at pi over 4, I'm going to go negative 2.8 in that direction. So let's go ahead and plot that. 2.8, how about right about there? So notice I'm getting negative values as I go from pi over 6 to pi over 4. And then I'm going to plug in pi over 3. Let's see what happens here. When I plug that in for theta, I triple it, and I'm going to get pi. Cosine of pi is negative 1 times 4. I get negative 4. So at pi over 3, I'm going to go 4 in the opposite direction, and I'm all the way out here. So this graph is very, very quickly going out with negative r's in the opposite direction. And then after pi over 3, we'll do pi over 2. Times 3 gives me 3 pi over 2, and the cosine is 0 times 4 is 0. So at pi over 2, I'm back at 0. So I know that this graph is coming back in like that. All right, and then 2 pi over 3. Multiply by 3, I get 2 pi. Cosine of 2 pi is 1 times 4 is 4. So I'm back at positive r's very quickly. So between pi over 2 and 2 pi over 3, so on my graph from here to here, my r value is going from 0 all the way to positive 4, which is quite a drastic change, at least in my mind. So we're all the way over here. So this graph is coming out like that. All right, and then we're going to go to 3 pi over 4. I fear we're going to get another square root here. When I multiply by 3, I get 9 pi over 4. What's that? That's 8 pi over 4 all the way around, and then another pi over 4. So I'm going to get a positive root 2 over 2 when I do the cosine of that angle. And then times 4 gives me 2 root 2, which is the same as the square root of 8, which is, again, approximately positive 2.8 this time. So at 3 pi over 4, we're going to go a little less than 3 units out there. And then 5 pi over 6. Let's see what happens here. When I multiply that by 3, I get 5 pi over 2, which is 2.5 pi. So I get a 0, because the cosine of that is 0, times 4 is 0. So 5 pi over 6, I'm back at 0 again. So my graph is quickly coming back down to 0. And now I'm going to start getting negative r values as I go from 5 pi over 6 to pi. Plug in pi, I do the cosine of 3 pi, which is negative 1 times 4 is negative 4. So notice on my graph here, so between 5 pi over 6 and pi, I'm going to start getting negative r's. So I had 0 at 5 pi over 6, and now for all these angles, I'm going to have negative values over here. And at pi, I get a negative 4, which is going to complete my graph and finish off the first leaf that I started, first petal, and I'm done. And so I know that I don't have to go any further. So on the first graph, when it was a 2 theta, I wound up going 0 to 2 pi. But when it's 3 theta, I only had to go to pi to get a complete graph. Now the petals all have length 4, because that was the number multiplied in front. So that pattern held. But for 3 theta, I wound up getting 3 leaves instead of the 4 leaves that I got before. So maybe it's about time that we should look at some patterns for these.